What up, gamers? No, I'm just playing. This is this is a video lecture for Math 1314, section 2.6. We're doing combinations of functions, and this is just so much fun. Again, and lots of fun. And so I never noticed that. It's so cool. Okay, so there are a lot of topics in this particular section, and some of them are a little bit more lengthy, and that's gonna be fun, like I said. So it's gonna be fine. We're gonna do it, and here we go. They're starting to talk about domains, and I know they're talking about rationals, blah 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 blah, and zero, I guess. Anyways, so domains. There's two things that we need to look out for: is divide by zero or square root of negative numbers. Now, some of y'all might be super clever and say, "Oh, that's it's imaginary." Not in this class. We're just saying it doesn't work. So, hey, that's kind of nice, isn't it? No imaginary numbers. But we're looking out for these two things. And so, if you see division at all, then I want to know, when is the bottom equal to zero? If you see a square root ever, then I'm going to say, hey, when is the inside? When is the inside equal to zero? And I'm going to find out those because, again, square root of 0 is equal to 0. That's cool. But negatives are no good. So I'm looking for where these hot points are and then going from there. For the bottom equals 0, we're looking for a hole. And here I'm going to say a start point, but it could also be a stop point depending on what's going on. A little bit of Devsmos will help once in a while, kind of. So let's do it. It says, find a domain. Do we have division? Yes. So I'm going to set the bottom equal to 0. I'm going to solve for x. Minus 3 on both sides. There you go. There's my hole. Circle. Because it's not actually the answer, kind of. So I have a hole in my domain. What I need to do is go around that hole. And so I got negative infinity over to negative 3, union negative 3 to infinity. There's my answer. That's what they want. That's my domain. We're done. Now, I just jumped it on you. I said, oh, here's the answer. And wham! I get that. And I'm going to show you in a different color right quick. Rip. This section, this part is from that hole. If I had a different number here, I would just put that number here. What if I had a negative 8 instead? Well, then I just put a negative 8, and there it is. I mean, it doesn't matter the number. It's the format. It's the style that we're looking for. And in a way, that is what you're going to put for any hole. You'll put this union-y thingy, and there you go. So let's do another one. I want to do it like an analogy with you guys, but I'm holding off just for a little bit on that, okay? So here we go. Do I have division? Yes. Bottom equals 0. Solve for x. Now, this one I'm going to actually just add x to both sides. I know it's a little weird. I got x equals 3. Yet again, there's a hole. And so now I got negative infinity to 3, union 3 to infinity. There you go. And we're done. There is your final answer. It's just that easy. It truly is, okay? Until you get to this one. So, do I have division? Yes. Bottom equals 0. What I need to do is factor this guy. So, when I factor it, I'm saying what two numbers add up to 16 but yet multiply to 39? 39? Isn't that like 3 times 13 or something? Boom. 3 and 13. Those work. And so when I solve for x, I get a negative 3 and a negative 13. Those are both holes in my domain. So when I write this out, here we go. Starting from negative infinity, the next thing coming up is negative 13. Union. Negative 13, we go all the way to negative 3. Union. Negative 3, all the way to infinity. There you go. We're done. I want to do a car analogy with you, and I'm not going to go too deep with it, but I will want to show you just a little bit, okay? So everyone drives cars or has ridden in a car and all that kind of stuff. Cool. So here we go. We're going to drive, you and me, we're going to drive from California all the way to Georgia. Okay, so we're staying down in the south. And we're going to go from California to Georgia. And there are mile markers and there are potholes in the road, because that's what happens in the road. Along the way. And so there is a hole in the road at mile marker negative 13. Okay? There's a pothole in the road. So when I'm driving my cool car, hold up. We got to drive a cool car. Okay? So here we go. Look at that cool car. Look at that whoa, car. So when I drive, I want to go around that pothole. I don't want to hit a pothole. And then here at mile marker -3, there's another pothole, so I'm going to go around it and keep going from negative infinity off to positive infinity, okay? Now, why did I go around it? Oh my goodness, I've seen, it's a union, oh my gosh! You were thinking, no, you're going to go over here. No, there's a car here, stop it! It's illegal. Union. Anyways. And again, if you're going like on the number line lane and stuff, we're talking zeros right there, and here's like +3 and da-da-da-da-da, all the way down. We're just going from the most negative to the most positive. California to Georgia, we're good there. Keep moving. All right, so now we're talking about square roots. It says you cannot take the square root of a negative number. So again, we're looking for a square root of 0 because we like that. But as soon as you make it negative, 0.00001, put a 1 in there, and is no good. So 0 is kind of like the defining mark. And again, I call it a start point, but it could also be a stop point. But we're going to see that here in a second. So do I have division? I'm asking the same question from above, right? Do I have division? Nope. So I don't have to care about that. But do I have a square root? Yes. So I need to say, set the inside equal to 0. And so then 3x minus 6 equals 0. Move the 6. Divide by the 3. 2. And this is a start point. I'll get into like the differentiation between start and stop and all that stuff in a little bit. But for right now, 2 is my start point. So my answer is very easy. I'm going to do bracket square brace, 2 to infinity, and we're done. There it is. Nothing else to do. Very simple. And so how would I do that in my car analogy? Because I love the car analogy, right? So what I'm saying is at mile marker 2, we actually have a checkered flag. Ooh, look at some flags going on. And so you see this checkered flag going on here. You pull up with your car and you're like, ooh, it's a race. Boom! And you go off to infinity. You're starting at 2 and you go off to infinity. There it is. There's your car analogy. Let's do it again. So do I have division? Do I have a square root? Yes. Set the inside equal to 0. I'm going to move the 3x over instead. Divide by the 3. These are all simple moves. And I got a 10. Again, I want to say it's a start point, but here I can't. It's actually a stop point. The reason why is because there's a negative in front of the x. It's a negative x component. So it's actually a stop point at 10. Back to the car analogy for just a second. I'm saying at mile marker 10, we have the checkered flags. Okay? I always will call it as it is. I have checkered flags at 10. And so then you come upon it. You're like walking through the forest. Let's do some forest action. You come from the forest and you're like, oh, look at that. It looks like a checkered flag. Is that where they start the race? Or is that where they stop the race? And you see like a lot of people standing in the road and are like, yay. And so then my car in this particular case is going to stop. These people are fine. They are fine, okay? They're fine. From negative infinity all the way until 10. I'm going to negative infinity up until 10, and then I stop. Done. So right now, I want to pause. Because if I made that a little bit confusing with like the negative, the main thing I'm saying is like the negative right there. You can actually use Desmos. So today's sponsor, no, I'm just playing. I love that joke though. So 3x minus 6. Notice that I start at 2 and I go to infinity. Oh my gosh, where are we going? We're going to infinity. But we're starting at 2. Easy, right? That was easy. Okay, let's do the other one. So I got square root of 30 minus 3x. See, look, I'm starting at negative infinity. Negative. Stop at 10. There you go. Cool. So Desmos helps, and I would say Desmos works for these guys with the square roots. They do not really work well for these. And I would have pulled it out. I would have showed you. It's not worth your time. I say move on, okay? I say move on. This guy right here is kind of a mix. So I'm going to ask same questions. Do I have division? Yes. Bottom equals 0. Solve for x. We get a negative 3. That's a whole. Do I have a square root? Yes. Set the inside equal to 0. Solve for x. I got a 5. That's a start point. But rather, it's not. Look, it's negative x. It's a stop point. So I got these two things going on. And so let's do this. If this is a stop point and there's a hole and all that, let's just do some car analogy here, right? So at mile marker -3, I got a pothole in the road. And then here at mile marker 5, here's like 0 somewhere around right there. At 5, I got the checkered flags. It's getting worse and worse. We got some people standing out there. Yay, you're doing so great. And so I'm coming over here from California, and I go around the pothole, and then I stop right there. Stop. Again, I could verify this is a stop point. I would say, let's just pop this thing in to Desmos. So I got square root of 5 minus x, and then I got x plus 3. So I know that there's like this break here. That's that pothole business. Again, it's not really that great here in Desmos. But I could definitely tell you that I stopped here at 5. Where's the rest of the graph? It stopped. Stopped at 5. Done. With these in mind, I started in California. I went around the pothole in Arizona. And then here in Texas, I stopped. Done. I don't know, man. Maybe it was New Mexico and Texas. I don't know. Anyways. I'm having fun. So, moving on. New topic. Brand new topic here. Oh, here we go again. Okay, new topic. So, algebra of functions is a lot of blah, blah, blah. But basically, we're going to be adding, subtracting, multiplying, dividing two functions. Here we go. No way Desmos can help you here. Got to do it by hand. So, it says find f plus g. So, I'm just going to say this thing plus sign this thing. That's all I'm doing. Look, we just did it. Yay! Combine like terms. So we got 6 x's minus 1 in the end. We're done. Let's do it again. F minus g. So I got this thing. Oops. Minus this thing. Yay! No, This thing minus this thing right here. I have to use parentheses here because that minus sign will distribute. Here, plus sign don't matter. Here, you do it again. There you go. But it don't matter. Here it does. 5x minus 9 minus x minus the 8. Combine like terms, we've got a 4x minus 17. You will get it wrong if you don't use the parentheses. So I suggest starting right now. F times g. F times g. So, what I'm doing here is multiplying them. Side by side, we have to FOIL. Yep, here we go. So 5x times x is 5x squared. 5x times the 8 is 40x. 9 times the x is the 9x, and 9 times 8 is 72. Combine like terms. And, well, there you go. Not the greatest, but it's not too bad. And then finally, last one, I'm running out of room. I put the top one in the top, and I put the bottom one in the bottom. Is there any way for me to simplify? And I know you're thinking, cancel the x's! No. Nuh-uh. You can't do that because the minus and the plus signs and all that other stuff is in the way. Don't do it. Don't do it. It's done. It's done. That's it. It's done. Wow. Whew. Man, that was great. So anyways, yeah, all this is not done. It's not really done. It's not really done because we got to find a domain for each one of them. Yeah, this is often what I do. I skip all that other stuff, but that's fine. I'm going to look at this and say, all right, I want to find a domain. As in like the stuff that we were just doing, right? Car analogy, start, stop point, holes, all that stuff. Here's my question. Looking right here, just right here. I got a question. Do I have division? Do I have a square root? No. Well, then you're fine. You go from California to Georgia. It's great. You're done. And it's just like that. And that's the default answer when you have nothing else going on. Let's do it again right here. Do I have division? Do I have a square root? No. Default answer. Do I have division? Do I have a square root? A root. I know I have a square right there. That's not what I'm talking about. A square root. It looks like this. Do I have any of these guys? No. I don't. Do I have division? Yes. I do have division right here. Bottom equals 0. Solve for x. -8 is my whole. And therefore, I have to go around it. -8 with the union thingy all the way to infinity. And there you go. We're done. That's the only one that's a little weird, is that domain right there. This is the only one that I would say is a little on the strange side. But that's fine. We did it. It looks great. Whew. Back to black. Here we go. All right. Do it again. You know what? I'll let you do this one. Next question. No! Don't do that to me, Chad. There's a typo on this one. There's a typo right here. It's a plus sign right there. That's a typo. Watch out for that, okay? It's a typo. Okay, so it says do the same thing. F plus G. So I have to add these together, and I guess I'll see in like 10 minutes or something. I don't know. Combine like terms. 35x. 24. Okay. I already know that we're going to talk about domain. Is there any division? Is there any square roots? No. No, no, and no. Okay. When I subtract, I need parentheses at least around the back end here. Distribute, combine like terms. I'm not concerned about this problem. It's not hard in the end. FG, this is just meh. What was I doing? I was writing down the wrong problem. Sorry. This one here, I have to multiply, and I'm going to go slow. I was doing fast for all those because it's whatever. Oh, I guess that's an answer. Anyways, this one I'm going to go slow on, and then, oh my gosh, I don't have enough room. Yeah, I'm going to have a lot more room somewhere. I'll figure it out in a minute. Okay, so what I need is to multiply this thing, and I'm going to go slow because this is big, man. 4x squared times x is 4x cubed. 4x squared times the 8 is 32x squared. 34x times x is 34x squared. 34x times the 8, pause. 34 times 8, 272x. 16 times x is 16x. 16 times the 8, 128. Combine like terms. That means like these two and these two. 66. 288. Man, is that just not the most ridiculous thing ever, man? Why? What am I going to use this for, Chad? No response, no response. It's a video. I mean, come on. I don't know you. But I could talk to you in person, or you can chat with me or something. All right. That ultimately is still not the worst. There's still another part. It's the division. I have to have more room for this. And so I'm going to erase my typo thingy, and I've got to write up here. I have to get more room. Like, what if I just tap it? No, I haven't figured out how to make this thing work. Erase the 0. Erase. Thank you. Okay, so I'm dividing it. F divide by G, and it looks like this. Okay. Now, have you learned long division? No? No, that's another section coming up. Okay. Have you learned synthetic division? No, that's still later. Yeah. Have you learned factoring? I guess. I mean, that top here it could be factored, and maybe, I don't know. Yeah, I guess that'll take forever. So let's talk about this problem. This one problem. It will be on your homework. And when you see it, you have to assume something, okay? You have to assume that it can simplify. You have to assume that one of these factors in the top will cancel with the one in the bottom, leaving you with a single one easy factor, and then you're done. Okay, so that's the goal. That's my goal, is to assume this action. With that in mind, it actually is pretty simple. You see, this 16 is 8 and something else. It's a 2. And notice everything's positive. This 4 is a 1 and something else. It's a 4. And so what you can do with this problem is assume that you already know there's a 1 and an 8, and therefore, how are you going to get the 16 and a 4? You have to get some other numbers to make it work. There you go. There you go. Is there an easier way in Desmos? Maybe. I don't know. Probably not. But this is probably the best way. Okay? Assume that there's a factor. Just look at it again. That's what I say. Now, looking at this guy. Do I have division? Do I have square root? No and no. But the answer was actually with a -8. Oh, why? I thought there was no division here. Because there was a division here. Solve for x is -8. Still a whole from the original. I know, that's a tricky one, man. That's a tricky one. And I know that that's why I'm showing you. I have to show you these things. All right. Moving on. Something else that's fun. So here we go. It's a running joke. So here we go. What they're wanting here is f of g of x. It's composition functions. And so this f of g of x, there's a little 0 thingy, but that means like of, I guess. And another way to write it is f of g of x. Notice that the g here is tinier, smaller, inside, something like that. And what I'm going to do is take the g and plug it in here. I'm going to take this whole g and I'm going to plug it in right there. Okay? For part A. So then I've got 4 times blank minus 3. This was my original. This is my original outside. But I said, well, what goes on the inside? I'm going to plug it all in. Here we go. So 5x squared minus 3. I just wrote that in there. I said, hey, this guy right here, replace it. Boom, with that guy. We did it. Now I need to simplify. Distribute 20x squared minus 12 minus 3. 20x squared minus 15. There's your answer. We did it. Okay. Let's do the g of f of x. Notice that the f is now the one on the inside. You know what? I'm going to use a different color. Let's go with... I've been doing a lot of red. Let's do some blue. So what I'm going to do this time is take this and plug it in there into this x. So I had 5 times blank square minus 3. What goes on the inside this time? 4x minus 3. This one's a little bit more complicated to simplify. I am so sorry. Like, shouldn't I just take that? So here we go. Keep the 5 in the front. 4 times 4 is 16x squared. Negative 12x. Negative 12x plus 9. Distribute your 5. Whew. All right. No, there's not a better way in Desmos. I would do it. I really would. This is negative 24 times 5. Yeah, I don't make this stuff up, man. And then we got 5 times 9 is 45. Still minus the 3, so we're still not done. There we go. We did it. There it is. All right, and we're not totally done. That's good enough. That's good enough. But we're not totally done. What they're wanting to do is plug into each one of them. And this one I am going to use the red for it. So red. Whoop. Okay. So my final answer right here, I'm going to plug in -2. So I got 20 times -2 squared minus 15. Calculator for sure. There you go. So there's your answer to part C. So this was A, this was B, this is C, and then finally right here I'm plugging in -2 in there. I'm doing this because I like you, okay? I don't have to do this. No. Part D. There you go, calculator. Woo! Oh my goodness. Okay, we did it. Are we done? No, we're not done. Do it again. This one's way easier, actually. It's so much easier. But back to black. Here we go. Okay, so they're wanting to do the same thing. I'm going to take my g and plug it in here. So my f of g of x, part A, is the square root of blank. What goes inside of that blank is this x minus 2. There's not much else to do here. You're done. That was it. G of f of x. Now we're going the other way. We're going this way. So then I got blank minus 2. What goes inside the blank is just the square root of x. So the square root of x, whoop, minus 2. Notice that I stop it, and I put a little, like, whoop, little down thingy saying, hey, this is done. That way I don't get confused, okay? They say plug in a 3 into both of these, and so, like, part next, you just plug in the 3. Square root of 1 is a 1. Here, I'm going to plug in a 3, so square root 3 minus 2. I'll wait. You're done. Oh! Yeah, it's just, that's what it is. I'm sorry. Okay. Oh, man. Oh, man. All right, these are easy. It's not too bad. So do it again. I'm going to take this and plug it in right here. So my f of g of x is 9 times, and then I got x, got a fraction actually, x plus 6 over 9, and then minus the 6. What happens is that these 9's cancel, and then these 6's cancel, and you get x. That's pretty cool. Yay, that was fun. And then I'm going to do it the same way. This goes in there. So I got blank plus 6 all over the 9. What goes inside here is the 9x minus 6. Notice it right here. 6's cancel. 9's cancel. You get an x. Now, this is actually useful for the next section. When you get just x, when you do it both ways like that, they're inverses. They're inverses. Again, that's not right now. That's going to be the next section. But it is pretty cool. Now, it says to plug in 3. Plug a 3 in right there. Come on, put a 3 in there. What do you get? Oh! Same thing here. Oh! Yeah, I know. It's whatever. All right, last page, I think, right? Yeah, okay. See, inverse, I told you. Oh, I can't even draw there. Anyways, so that's okay. So last bit, we're almost done. So it says f plus g at -2. What they're saying is f function plus the g function at x equals -2. So x equals -2 is right here, and I'm wanting the y values. The y values, you're going to add the y values at those points. So what's my y values here? I got a 2, and here I got a 3. So they're saying 2 plus 3. What's 2 plus 3? It's 5. Done. Now, I want to repeat this one again so that we're understanding like what's going on here. Let's do another one. I'm going to do f minus g. F minus g, but at, let's do 3. So I'm looking here at 3, and I got this one, and I got this one. My f at that point is a -4, minus sign. And then this one's a 1. So what, -5? There you go. Anyways, cool. And then we got f of g of x. So it's actually this way. I'm going to find the g of 5 first. So I got, there's my -5. Find the g up and over. That's a 2. So now that's a 2 in there. So then they're saying find f of 2. Oh, well, I start at 2 then. Up and over. We got a 4. It's a 2-step process. Again, note that I'm saying g at -5. So start at -5, go to the g. G is red one. And then that's where I start for the next guy. So I start at 2, go up and over. Done. I got hopscotch. I don't got hopscotch in this? I thought I had hopscotch. Oh, that's the next section. Oh, yeah, that's right. That's the next section. Okay, we'll do hopscotch next time. All right, that's all I got. Thank you very much. Have a great day.